And we're good to go.
Sweet.
So, oh gosh, I'm totally forgetting what we normally do. We normally go over part one and then go into part two. For some reason, I suddenly can't remember what we do.
No, that's okay. I think even just for time's sake as well, it'd be good to go over part two since we have all the resources to fill out part one. If we have questions, we have those videos and stuff.
Right. Okay.
So let's see. It says, suppose pair computing sold an average of 45 P phones per minute in 2011. Yes, that means they sold 23,652 P phones in 2011 with a standard deviation of 10. And they looked at their P phone sales data and determined that they are normally distributed. What? So sample size of n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distributions of X? So I would say since the parent population is normal, it would be normal.
Yeah.
Yeah.
That's what I thought, especially with, I think, was it the central numbers theorem from the last lesson?
Yeah.
Okay. Yeah, with that, based off of what it says, I would say normal.
Sweet.
Okay. And number 5, sample size n equals 40 are taken from the normally. Why do they always say n? Or they say r? Sample size n equals 40 is taken from the normally distributed 2011 sales data. What is the shape of the distribution of x bar? It's going to be normal as well because your parent population is normal, and then the size of this the size of the sample is large enough.
It's
that
greater than 30.
it'll be normally distributed, yeah.
So it falls under both rules.
Okay.
It's double normal. Sweet.
Joe or Naomi, do you guys want to take 6 and read it, or did you guys get? I know, Naomi, you said you didn't get the chance to look at this lesson. Joe, did you look at this part at all, or do you want to just read it? And
Yeah, I did a class prep, and I know the reading and stuff, so yeah, I got it all done. So you want me to do 6 then?
Yeah.
Yeah, we'll just switch off.
Okay. The sample size of n is equal to 4 is taken from the normally distributed 2011 sales data. What is the probability that the mean of x is less than 40? So let's see. Our mean normally is 40, so it would be 45 minus 40 over standard deviation. So it would be like 45 minus 40 over 10 minus the square root of 40.
Yeah.
So I'm going to punch that in.
Does 40 come first? Is it 40 minus 45?
Yeah, so it is n.
What was that?
The formula for what we're going to be doing is, oh gosh, okay, x bar minus mu over the, and this is like the formula that they gave us for the standard deviation, so standard deviation divided by n.
Yeah, sorry, I had the wrong n value, so my n should be 4. So it would be 10, let's see, it would be 40 minus 45 over 10 minus 2, so it would be negative 5 over 8. So my z-score would be like,
Wait, how'd you get
65
10
or
over
something?
8?
Yeah, shouldn't it be?
It should be negative 5 over 5, because you do 10 divided by the square root of 4, so 10 divided by 2, which is 5. Then 40 minus 45.
Yeah, good point.
Z-score is
I'm reading
negative
my notes wrong, sorry.
is
Like, I got
-1.
scribbles here and stuff.
So then we just go to the applet and highlight everything
Okay, yeah.
of -1.
Ah.
So I have 0.841.
Let's see, I have 0.159.
Yeah, let me type that in again. Did you highlight everything to the right of the negative z-score of negative point or 1.0?
Was X bar is less than 40. So because our z-score that we got is -1.
Yeah,
you
so
don't
my probability would be like
take it
0.1586.
from the negative.
Oh, less than. So it's everything to the left.
Yeah, because look at it like this. There are some other problems later on that will give us well, let me look at one. Okay, so actually number 7 is a really good example where it talks about a sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X bar is greater than 35 and less than 55? And so one thing I like about the problems that have both, like they're equally distant from the mean, is you can use the positive one, because one thing I remember from a logic class I took is you try to keep things as positive as possible. It makes it easier to not have to deal with negative things.
Mm-hmm.
And then taking it a step further, if you look at the information they gave us earlier, 45 is the mean and the standard deviation is 10. So 35 and 55 are both exactly one standard deviation away. So you know that it's going to be 68% of the data, which is a 0.68 probability.
Ooh. That makes sense.
Naomi, Joe, did you guys follow that?
Yeah, I did.
Okay. It saves a little bit of time of not having to go through and do all the work.
Okay. So you on that next one, Naomi?
Yeah.
Sweet.
What number is it? Sorry, 7, right?
8.
Yeah.
8?
I just did 7.
Wait a minute. I think we just did 6, didn't we?
No, Joe read 6. That was the one that the answer should be 0.159.
Oh.
And then I was reading number 7.
Oh, okay. Sorry, I wasn't following.
We're on 8.
Nice. Okay.
Yeah.
Okay, a sample size of what?
Go for it.
A sample of size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the x or the mean is greater than 41 or less than 49?
Ooh.
So this is another one. You're given 2 points of information, or 2 numbers, 41 and 49.
So do we need to find the z-scores for each?
No, they're the same distance from the mean.
Oh, okay.
So the z-score for 41 would be the negative version of the z-score for 49. So rather than have to deal with the negative, just figure out the z-score for 49.
Oh, that's cool.
Because they're going to be the same number, just negative. One will be negative, the other one will be positive.
Oh, that's cool.
Oh, okay.
That's a way smart rule. I'm glad you pointed that out.
What was the rule again?
Well, it's not really a rule, but it's just something to make life easier. If they give you 2 numbers that are the same distance from the mean, so 41 is 4 less than the mean, which is 49 or 45, and then 49 is 4 more than. So rather than taking the time and dealing with the negatives and messing with 41, just work with 49, because the z-score for 41 will be the same number, just with a negative thrown in front of it.
Oh, okay.
So I got -2 as the z-score, and it'll be a +2 for 49.
You got -2?
Yeah. If that's right. Wait.
5.8.
Wait a minute. Oh, I might have done that wrong, because that's 5. Negative 4 divided by.
So you should have gotten. Okay, yeah, you should have gotten 2.
I got negative 0.8 that time. Wait a minute.
So 49 minus 45 is 4, right?
Right. Is it?
Mhm.
And
It
then
should be
10
negative 4.
divided by the square root of 25. So the square root of 25 is 5. 10 divided by 5 is 2. And 4 over 2 is 2.
Oh, yeah, that's right. Okay.
Yeah,
so
I'm still.
Okay.
Sorry.
And we're going for the one in between.
So it says we're trying to find what's greater than 41 and what's less than 49. Oh, yeah, so we just highlight the area in between.
Yeah.
I love this.
So, and that actually, if you remember the rules that we had for the probabilities, that is like the 96th percentile. And so rounding, it gives us exactly 95 or 0.9545. But rounding, it would be the 96th.
Yeah. I wonder if we could have used the 6895. Oh, yeah, we totally could have used the 6895 99.7 rule.
Yeah.
Because that 99, 95.
Yeah, we could have.
It was 2 standard deviations from the mean. Oh, that's weird.
What's weird?
Oh, I was just doing. Never mind. That doesn't make sense in my head. I was trying to think deep. That was weird. Okay. Number 9. A sample of size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 50? So same thing. We compute the z-score, and then we find. So we do 50 minus the sample mean of 45, which is 5. Over 10 to the square root of 25. So that would be 10 over 5 is 2, and then 50 is 5. So 5 over 2, right? 5 divided by 2.
Yeah.
Mm-hmm.
And then that comes out to be 2.5. So then we just need to jump over to our applet. Type in 2.5 and then highlight everything to the right of it. I believe. Is it asking for greater?
Yes.
Yeah.
So then the answer would be 0.006.
Yeah, I got the same thing.
Okay.
Sweet. These problems are good.
Yeah, that's a good one.
All right, let's see. Are you up, Dylan, on number 10?
I can do it, sure.
Sweet.
All right, so paracomputing sold an average of 40 P phones per minute in 2010 with a standard deviation of 12. They looked at their P phone sales data and determined that the distribution is right skewed. So the sample size of n equals 4 taken from a right skewed 2010 P phone sales data was the shape of distribution of X bar. I said right skewed as well.
Yeah, that's
To
right.
follow the data that the parent population had because the sample size is so small.
Yeah.
Mhm.
And then I think Joe's on the next one if we follow that same pattern.
Okay. Sample size of sample of size n equals 40 are taken from the right 10 P phone sales data. What is the shape of the distribution of the mean of X? So it would just be normal distribution, right?
Yep.
Because it's a 40 size sample size of 40.
Yeah.
Solid. And then question 12 is a lot like 11.
Yeah. Is there a theorem that justifies your answer to question 11? What's the name of the theorem? The central limit.
Central
Nice.
Yeah. Good call, good call.
Alrighty, 13 says a sample of size n equals 4 is taken from the right skewed 2010 pphone cells data, and you want to know the probability that the observed sample mean is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why? And it is no, because it is not a normal distribution, because sample size isn't large enough and it's right skewed, so we can't use the formulas to compute it.
Okay.
Okay.
I think that's right, at least. Because from the reading, it never taught us how to do that in not a normal distribution.
Right, so then I would agree.
Good call, good call.
Right, so 14. A sample size of n equals 36 is taken from the right skewed 2010 pphone sales data. What is the probability that the observed x is greater than 36.5? So you follow what we did earlier.
36.5 minus 40 equals.
Greater than 36. So I got 0.040 or 0.04.
That's what I got. For the z-score?
No, for the z-score, I got 1 3/4.
Oh, yeah, sorry, I typed this
And
in.
then for the probability, I got 0.04.
You did everything to the left then for less than?
No, because it's greater than on 14.
Oh,
And so you do everything to the right of the right-hand z-score, or the positive z-score.
sweet. Nailed it.
Okay.
And then 15. I wonder if 15 follows that same rule if they're both the same distance from the mean. They are, right?
Yeah,
They are,
15 would
yeah.
follow that same rule, where they're both 2.5 away from the mean, that you would only have to solve for the positive one, and then be able to get your answer from there.
And highlight the blue area just in between the z-scores.
Yeah.
All right, so for that one, I got... You know what? I actually had a question from part 1 on these, because I went through and checked my answers on part 1.
Okay.
And let's see, for the z-score...
Let's see.
No. Oh, okay, no. Just kidding. I remember what I did wrong. That makes sense.
Which one did you mess up on?
I just noticed how there was kind of a different formula to get it, because they would take both the z-scores and they would, like, for instance, on this one, it says that the z-score for each of them is 0.1056. So
The homework does? Or the... I don't even know what I'm trying to do.
sorry. No, sorry. The z-score is negative 0.125, right?
Well, it would be positive and negative 1.25.
Yeah, exactly. And then the area between is 0.056, correct?
The area between z-score 1.25 and negative 1.25.
Is, so when you highlight the area between, does it say 0.1056?
It says 0.7887.
Yeah, that's
rounded
what I have.
0.789.
Okay. Yeah, that's where I was messing up. I was just looking at the answer key for the part 1 earlier when I was preparing for it, and it takes 1 minus that, like the z-score, and then the other z-score. I guess it just kind of lays out a more different formula to get it that's way harder than just highlighting the blue area, so I just confused myself. But I'm good now. I got it.
Okay.
0.788. Sweet.
Okay.
Should we take the quiz?
Yes.
Sure.
Sure.
I think my computer's having to work like really hard right now for some reason. It's like getting hot on me.
You have to be done by 6, right, Naomi?
Yeah,
Okay.
6-ish.
Okay, there's 15 questions on this one, so
There's only 15.
yeah, there's 15.
Yeah, 15.
True. Okay. So number 3 says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score 1.358 and to the left of 1.358, negative 1.358. Ooh, that's nice. It just gives us the
Yeah.
z-scores.
And we just find the middle, right? The area in between.
Yeah.
No, this one is asking for the outsides. It's
Oh,
asking
yeah,
for the
yeah.
right of the positive
Oh,
answer and the left of the negative. So we want the outliers.
Yeah, that
Oh.
makes sense.
okay.
Good call. So it'd be 0.175.
Yep.
0.175. Solid.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. Oh, that's depressing. Standard deviation of passengers' weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimal places. Note if the answer is 0.0 or 0.8976, then you would enter 0.898. Now, as extreme or more extreme means that we are only interested in the values that are lower than the ones we observed, but also values that are as far as away from the mean as ours in the positive direction.
Okay.
Okay.
So
Let's see.
So I know kind of what we need to do off the top of my head.
Do we need to... So what's like the first steps in solving this? Like, do we find the z-score? It's kind of interesting. It gave us 2 means. Gave us the...
Okay. We're going to want to use the sample mean.
Right.
177.6 pounds. We'll still use the 26.7 as a standard deviation.
Mm-hmm. And then we have a random sample of 48 passengers. But then it's saying I guess I just don't understand what it means by extreme or more extreme.
So is that just the z-score or like the area?
So
Is it-
that's going to be the area. So you know how on 3 it asks us for the area on the outsides of the z-score?
Oh, is it the same type of deal?
The same data. So that's what we're going to be using is that same data.
Mhm.
I'm just trying to think.
So we're looking for everything that's bigger, further away than 1 standard deviation.
Okay, so guys, use this formula for your z-score, okay? X bar, so the very first 48 minus the 177.6
Divided by the standard deviation.
divided by, and it's going to have to be 1. Yeah, so 26.7 divided by the square root of 48.
Are you sure?
Mostly sure.
'Cause
No, my bad. 1. Use the square root of 1.
square root of 1?
Yes.
Or do we need to do that formula? Because I know there's a formula where you don't need to take the standard deviation and divide it by a square root.
If you can find that formula, then sure. I'm just, based off what I remember what I talked about with Sister Cook earlier, so we're doing kind of an individual observation of X number of passengers. We're going to use the same number of passengers, and because our individual observation is 1 time, N is going to equal 1, and X bar will be 48 for the number of people that we're looking at.
Oh, okay.
So, I mean, if you want to try and find that formula and then use it, I'm game, but...
Yeah.
Ooh, I don't know about
Is it just your class?
What?
Is as extreme or more extreme?
Yeah, that's not going to work. Because that is way outside the range of what we want to be.
So yeah, I think we would compute it. Let's check. Because I mean, going back to a few lessons ago, couldn't we compute a z-score? Just a very
Yeah,
simple.
without.
Yeah,
Uh-huh.
like the formula to compute a z-score a few lessons ago was super simple.
I think it was the same thing, it's just not square root.
Z equals X minus the mean over the standard deviation.
Yeah.
Yeah, because this, I think it is a different kind of problem because this never talks about like a normal parent population and all that stuff. So I don't think it's like a distribution or something.
Okay.
So if we just found a very easy z-score, like from that formula, let me go back and check what that formula is.
Well, I found it in lesson 5. Z equals X minus the mean over the standard deviation.
Ooh, nice.
But using 1 as N, that's basically the same thing that we're doing.
Oh, really?
Yeah. Because any number divided by 1 is the same number, so 26.7 divided by 1 is 26.7.
Yeah.
So it's going to be...
So even if we did 48 minus 177.6 equals, divide that by the standard deviation of 26.7. Yeah, that's what I got before too, the negative 4.85.
Yeah, and plugging that in for the z-score is absolutely disgusting.
Is it?
Yeah.
Oh, that makes sense. Oh, well. Yeah, I wonder why that doesn't work. Because it's above the 8 or whatever.
Yeah. I saw it, but I haven't watched it yet. Why?
So did you get the crazy area of like 1.2100 e to the negative 6?
Yeah.
Mm.
And this is asking us to round our decimal to the third. Yeah, that's definitely not
Which
the
is
answer.
impossible with that number.
All right, let's see. Man, yeah, we never did a problem that talked about like the extreme or more extreme thing. Should we just for the sake of Naomi, should we go on, just kind of skip this
Isn't that just
one?
the p-value?
Because we could go on and just get as many done as we can. Just skip that one, and then if we have time, come back to it.
Yeah.
Okay.
So let's just skip on to 5. So I think, let's see, whose turn is it?
Joe's.
Joe's turn.
I think it's my turn. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of individual observations, X. The distribution of sample means, X. And this cannot be determined from the given information.
Of a smaller deviation if 9 observations are randomly drawn from a population.
It won't be.
I think it's just.
It can't determine it.
I think it would be the middle one.
So the distribution of
X bar.
Oh, wait. So the distribution of sample means, so that's, in a distribution of sample means there's going to be a lot more like there's going to be a ton more experiments. So the sample mean is going to be more accurate, but honestly we can't determine the information because even if there were individuals observations taken, those could either be way high or way low. So
Yeah.
Yeah, that's what I'm thinking.
there's like not even enough information to determine that.
Okay. Is that, I don't know if that's, that is the absolute value of X, or not the absolute, the mean of, let's see, X, that's X bar, right? On number 5 in the middle thing?
Yeah, X bar.
That is X bar, right? Okay. I couldn't tell if it was something on my screen or not, I'm like trying to figure it out. But
Yeah, it's. I don't know if it's X bar or bar X. It's one of the two.
Wait a minute. Am I? But I guess it's asking for a standard deviation though. Because what I know is that the more samples, so the more samples that are given, the more sample means that we have, the smaller standard deviation we have. Actually, so Joe was right. So the distribution of sample means is X bar, because if you jump back to the lesson right before this, when you would have a huge population, like if you took 35 samples, the histogram would be like super narrow and tall, but individual observations, like it was much more wide because, like I was saying before, you could have a really high one and a really low one, so it's super spread out.
Right, but this isn't
Could you
telling us
actually-
how big the
like, what
population
do you
is.
mean?
For all we know, the population is super small. And this is just saying if you take 9 random observations from a given population, which will have the smaller standard deviation, X bar, or the information can't be given.
Oh, I see. Oh yeah, you only have 9 observations, huh?
Yeah, so I think the information
Yeah.
can't be determined.
Yeah, I'd be cool with that. I think I overthought it, but yeah, that makes sense.
Because, like, if you were said, like, okay, yeah, you've got so many from individual observations and then so many from the sample means, I would say probably, yeah, the sample means will probably give you a more accurate standard, or a smaller standard deviation. because those numbers are already going to be kind of tightly packed, and so when you go and look at those ones, it'll be even smaller standard deviation. But you just know that you get 9 observations from a population of any given size. It could be 10, it could be 10,000.
Yeah, that's true.
Yeah.
Okay, that makes sense. All right, so Naomi's up on 6, I think. Oh.
All right. Which of the following results implies that the spread in X bar decreases as the sample size increases? Or decreases sample size.
Somebody got a Facebook message.
Not sure.
So let's see. Which of the following results implies that the spread of sample X decreases as the sample size increases? I think that would be the law of large numbers. Yeah, it does.
The larger the number, the less the spread.
Exactly, yeah.
Use more data.
Yeah, because I know it's definitely not the first two, and the central limit theorem is all about normality of shape.
Right.
Yeah.
Law of large number is all about accuracy, so yeah, I'd say law of large numbers.
Okay.
Okay.
Mm-hmm.
So let's see. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So we would just need to do 160 minus 150.8. Let's see. Yeah?
Yeah.
Yeah, this is going to be like our really basic z-score calculation.
Right. Okay.
It's gonna be really close to 1.
Just the way basic one?
Yeah.
Alright, so all these formulas are messing with my head.
Yeah.
That's the fun part about me. You gotta keep them all straight.
So I got 1.045.
1.045?
Yeah.
Cool, me too.
Sweet.
For the z-score, and then you have to calculate the probability, don't you?
For number 8?
Yeah. Oh no, it's just asking for the z-score. Okay.
Yeah. Number 8 says what is the probability?
And selected. We'll score above 160.
So we just type that in on the applet. So above that, so I have 0.148.
Me, yeah. Yup.
Yep, that's what I got.
Sweet.
Mm-hmm. Whose turn is it?
I think it's yours, Jim.
Yeah, I think it's yours.
Mine?
Yeah.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So our 5 students, all it has to be is greater than 168 or 150.8. So
Have we already done number 9?
Yeah, we haven't done number 9 yet.
We're on number 9, I thought.
Yeah.
Oh yeah. Oh shoot. I typed number 9. Okay. Sorry about that. I typed number 8 into number 9, so I just jumped on to number 10. Sorry about that. And it was 1.148, right?
Yeah, 0.148.
Okay, cool. All right, number 9. A random sample of 5 students was selected to take the GRE. Their scores was 149, 153. What is the z-score corresponding to the sample mean of these students' scores?
Wow.
And so we take the mean of those, right?
Wow, this is a new
That's
one.
the first step. I think we just take the mean of those, and then that's our mean. And our standard, our number would be 5.
Yeah, that makes sense.
Wait, do what?
So
160 plus 175
Oh, gotcha.
plus 163 plus 149 plus 153. So you take them, divide them by 5. So you get 156.4. And then you just minus that with 150.8. Divide that by 8.8. So I came out with 0.636.
your mean again?
You guys?
I got 160 for the mean.
Yeah, I got 160 for the mean.
Oh, you did?
But I think this one is more complicated. I think this is the more complicated z-score formula. Because we're taking the z-score of
Oh, 5 cents.
a sample mean. And so it has to be 160 minus 150.8 divided by 8.8 divided by the square root of 5. Because
Yeah.
n is 5 in this situation.
Good call. That's true.
Oh.
Mm-hmm. What was our standard deviation again?
8.8.
8.8. Are you here for a while?
Okie dokie. I got my Z.
So then it's 160. So you take 160 minus 150.8 equals, and then divided by 8.8 over the square root of 5, huh?
Yeah.
So it's 9 point. I don't have a calculator that does square roots too good.
I got 2 point, and if I round it to the third, 2.436.
After you calculated it all?
Yeah.
2.436?
Oops.
Yeah. And then we're looking
I got
for
2.338.
well above. Okay. 2 point what?
Overtime.
You got 0.438. See, and I rounded it quite a bit. Did you round a lot, or were you able to do without much rounding?
That does a lot. What the heck?
What was that?
Man, I need a better calculator.
8 divided by the square root of 5.
7. That's probably not right.
Yeah, I just got 2.338 without
Yeah, I'm
having to
getting
round
5.264.
all my calculator.
What's that?
I just got 2.338, and I feel good about that.
Yeah, I feel good about that too. That's what I came out with.
We'll do that without having to round or anything, and yeah.
Yeah,
That's solid.
2.338. That's the right answer.
Okay.
Okay.
Mm-hmm.
So
I think
Naomi.
Naomi's up.
Okay. Hold on.
Very nice.
Number 10, right? What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Oh, great. These ones are easy. So we just need to type 2.338 into
And then round to the third decimal.
2.338. So it's 0.00.
Oh, this one says the 4 decimals.
Oh, so it's just 0.0097.
Yes. In other words, you have really, really small odds of scoring any better.
Yeah.
Which means these people that got 175 and 163 are geniuses.
Alrighty, number 11 says, suppose the mean of a GPA of BYU Idaho students is 3.5, standard deviation of 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use it for 11 through 15, and the shape of this is approximately normal because of the sample size.
Yeah.
Yep. So 12, what is the mean of the distribution of the sample mean sampling distribution of all possible samples of size 81 that could be drawn from the parent population? What in the world? So what is the mean of the distribution of the sample mean for all possible sample sizes of 81? Round to 1 decimal, please.
So don't we just use that same formula?
No, because we're looking for a mean, not a z-score.
What is the mean of the distribution of sample means? And then we have to find.
See, but the thing is throwing me is like for all possible samples of size 81. Well, for 81 sample size and the standard deviation of 0.7, there's anything.
Look in your game. It'll probably be done by 7.
Ooh. Tyler, can you open up that thing from lesson 6?
Uh-huh.
You remember the chart generator from lesson 6?
Yeah.
Can you open that up?
Uh-huh. Is that what we need to use?
I think it might help.
I got it all opened up.
Lunch, so. Oh.
Alrighty, so let's see.
I'm glad you know what I talk about when I say it's a thing from lesson 6.
Oh yeah, I gotcha.
At least I think it was in lesson. That chart generator.
Yeah. This thing I can't type in a sample size of 81 though.
Well, okay, but you can do. So do the 5. What times 5? 80.
Do you need to go soon, Naomi?
What?
Do you need to go?
At least by 6:15.
Okay. So type in what?
But okay, so you can take. Can you make it left skewed?
Yep.
Okay, and then do the 5. Okay, I'm actually there. Oh, I thought you could do a single
yeah.
as well.
You can only do right skewed.
Yeah, that's what I'm looking at. Right?
Oh, parent population.
Or
Can
can
be
we-
with mouse. Oh yeah, you can do a left skewed one.
Ugh.
Wait, how'd you make yours left skewed?
You just use the mouse.
And change all of it?
Yeah, you just draw a line with your mouse.
Well, that's fun.
Yeah, it's pretty cool, huh?
Okay.
Whoa.
That's my phone. Oh. Hey, Joe, what's up?
What is the standard deviation of the sampling distribution?
Sure thing. 1 second. Let me see if I can put you on speakerphone and you can chat with us. So Joe lost his connection, guys. Can you? So I just put you on speaker, Joe. Can you hear? I'm sure you can hear me. Can you hear everyone else well enough?
I think I probably need to hear you. That's about it. But I'll just, as long as I can hear you, that'll probably be perfect. Yeah. So let's just finish this up. There's a kid. My roommate needs me to come home. His girlfriend's coming over and everything is over there. So.
Got it. Okay. So let's go ahead and power through these guys.
So finding the mean, there's got to be a formula for this. What is the mean of the distribution of sample means? Sampling distribution. So it's just saying, what is the mean of the sampling distribution for all possible samples in size equal to 1? It could be John, the parent population.
We're still looking at 12.
Are you sure we wouldn't just go 12 minus 81 minus 3.5. So the sampling size is 81. So couldn't we just go 3.5 minus? Oh yeah.
So can I tell you really quick? I was able to get using that chart. I was able to get to 81. But I can't make n equal anything larger than 25. But I don't think that's a problem. Let me check really quick.
So 81 students. I'm pretty sure all we would need to do is.
And I got 23.07 as the mean.
Oh really? Using that
chart?
Chart?
Yeah.
I never used that chart to do calculations like that.
Oh. Okay.
That would be really cool if that was right, though.
Okay, so what were you saying for...
Well, we're trying to find the mean. What the...
Did you figure 12 out, Joe?
Suppose the mean.
Oh, that's right, your internet crashed. Okay. Okay, Hey, Joe, can I call you back later and we can talk through this so that I can focus? Okay. Okay, so go and shoot me a text or call me when your internet is up and working again, and I will get on and look at what we did. Okay?
What is the standard deviation of the sampling
Awesome.
variable x?
Bye.
The mean of 81 students who are selected. Round your decimal place to 3 decimal places. Are any of these problems on our preparation assignment?
Not that I remember. No, there's nothing like.
Doesn't sound familiar.
That's really weird. I don't like that at all.
Wait, what was the standard deviation of this distribution? There has to be a way to get this, guys.
Yeah. What is the mean, the distribution of sample means for all possible sample sizes that are size 81? So there's 81 samples drawn. The mean is 3.5. Standard deviation is 0.7. We know it's a normal distribution because it's above 81. I don't even remember, like, I don't remember reading about this even.
I'm gonna pull that chart back up and see if I can't get it to do what I want it to and make something work.
Yeah, maybe.
I think we could try 13 without 12, but to answer 14 and 15, we have to have 12 and 13.
Really?
Yeah.
So we need to find the standard deviation.
Yeah.
Give it to right? Which is it 0.7?
Yeah,
Or
the standard deviation is generally just the same number you pull down.
Oh my gosh.
What?
Is this the way? What if this is the way easy one that the answer is just 3.5?
Oh, I think you're right.
I'm so ticked at myself.
I think you're absolutely right.
And then the standard deviation is just
It's going to be the same
0.7.
standard deviation.
Oh my gosh.
Oh, wow.
I'm so ticked.
Was it 2 lessons ago that we had that happen?
It was, yeah.
Or just, it was last week or earlier this week, I don't quite remember.
So then we just take, for the 13, we take the square root of 81. Man, I always do that. I always make things way harder than they actually are.
Right? So, for 14, you would take...
13, you mean?
No, because
No,
13 is the standard deviation.
So yeah, did you calculate that one? You just do 0.7.
Oh, no, that's right. We do have to calculate that one.
0.7 divided by the square root of 81. And since you have the nice calculator,
Oh.
or let's see, I guess it's just 9.7 divided by 9, huh?
Wait, I thought this was the one that it just came down as well, like the sampling standard deviation.
Oh no, this one never came directly down. We always had to put the standard deviation above the square root of 81 of the sample size.
Is that what it was? It was the 0.7
Divided by...
9.
Square root of 81, yeah. So yeah, 0.7 divided by 9, which is 0.0777.
0.0778.
Yeah.
Or whatever. 0.078, because we're running to 3 decimal places.
Yeah.
So then for this next, but that seems like such a small standard, like too small.
That's okay. No, it's got to be right. Because look at how small the standard deviation is in general, 0.7.
Yeah, I guess you're right.
Yeah.
Okay. So what is the probability that the mean GPA for 81 randomly selected will be less than 3.3?
Oh, okay, this is one's...
So this is going to be 3.3 minus
Yes.
3.5 over the standard deviation divided by
Which
9.
is 0.07. 0.078.
Right.
I'm so glad we figured this out.
Right?
3.3 minus 3.5 equals divided by 0.078. So did you get negative 2.564?
Yeah, but that's the z-score.
Oh, yeah. And then you have to... And then what is it? Is it asking for greater or less than 3.3?
The next one's greater.
So you'd have to you do it to the left of the negative z-score. So I got 0.0052.
Okay, I can't pull it up right now, so I'm going to... Oh, there it is.
So yeah, it's 0.005. And then greater than 3.3, the answer is 0.995.
Well, you have to put the 0 in front of it, so it's 0 point, isn't it?
Yeah. So 0.995. Did you get the same ones for 14 and 15, Dylan?
Let me double check really quick.
Hey, they add up to 1. That's pretty cool.
Yeah, that's a good sign, because they should.
Yeah. Oh, yes, I feel so much better about that.
Yeah, 0.0052, and then 0.995, yeah.
And then we're rounding to 3 on each of those, so okay.
Yeah, so, okay, back to 4 now.
Okay, let's...
So are we overthinking 4 again as well?
Oh, I guarantee it.
I mean, if we're looking at the sample mean and we're trying to find the probability. So what if we use the sample mean as our x, and then n equals 1 again? So we would take 177.6 minus 185, and then divide it by 26.7.
I like that.
Okay.
And that's about as simple as I can make that, I think. Negative 0.277.
So we just type that in on the probability app.
And then what are we looking for again?
You'd highlight the outsides.
Yeah, the outsides.
So 0.7.
782.
If we get that one right, I'll be pumped. If not, I'm okay.
Right? Okay. If it's all done, let's go and hit submit and send this in.
Submit.
Bam. And 88. We missed 4. Yeah!
Oh, we missed 5 too. Oh, dang it.
It was X-Bar. I'm so sorry, everyone. I led you astray. But those were the only 2 we missed.
Yeah, that's good.
Go us. Go us.
Oh yeah. Okay.
Still have no idea what 4 is supposed to be.
Man, that one stumped me good.
I'll email Sister Cook about that and ask her what we should have gotten.
I'm so glad we finally figured out the last few.
Yeah, that was nice.
We're like, wait a second, we're overthinking this.
Alrighty, so you have the link
Alright.
to this one, Dylan?
Yeah, I'll send it. Naomi, do you just want me to post it again, or do you want me to send it to you to post?
It doesn't matter. I just have to go to a group meeting, so I'll be done by like 7:30.
Okay.
Whatever you want to do.
Okay, I'll just send it to you to be posted then.
Okay, sounds good.
Awesome.
Alright, see ya.
Alright.
See you
Alright,
guys.
good work, everyone.
Bye.